Now, we're going to take up one more problem on shafts. The problem number 15. It treats as a solid circular shaft is required to transmit 80 kilowatt at 160 rpm. The permissible shear stress in the shaft material is 60 Newton per mm square. The maximum torque transmitted exceeds the mean torque by 20%. The angle of twist is not to exceed 1 degree in a length of 20 times the diameter of the shaft. The value of rigidity modulus is 0.8 into 10 to the power of 5 Newton per mm square. Find the diameter of the shaft. So this is the problem which is given. So first we are going to write the data. Capital N will be equal to 80 kilowatt and small n will be equal to 160 rpm with the shear stress is 60 Newton per mm square, which is tau. Then we have T max will be equal to 1.2 times the T mean. So here 20% over the mean torque, where T is nothing but the mean torque. And also theta is 1 degree, that is 1 into pi by 180 radians. So in a length of 20 times the diameter, so L will be equal to 20 times the D. The value of rigidity modulus G will be equal to 0.8 into 10 to the power of 5 Newton per mm square. So since the power is given, first we are going to find out what is the T mean. So the power transmitted by the shaft, which is capital N, will be equal to 2 pi into N into T mean divided by 60,000. So substitute the values now. Capital N will be equal to 80. That will be equal to 2 pi into small n is 160 into T max. T is nothing but T mean, which is T mean divided by 60,000. So therefore, on cross multiplication and simplification, T mean will be equal to 4774.65 Newton meter. So therefore, the mean torque transmitted by the shaft, which is T mean, will be equal to RT, which will be equal to, which is 4774.65 Newton meter, which is 4774.65 into 10 to the power of 3 Newton mm. So now, what is the maximum torque? The maximum torque is 1.25 times the T, which is 1.2 into 4774.65 into 10 to the power of 3. So on simplification, you will get it as 5729.6 into 10 to the power of 3 Newton m. So once you get this value, then we want to go for the diameter of the shaft based on the strength. So what will going to be the maximum torque transmitted by the shaft? T max will be equal to pi d cube by 16 into tau. So here we have the maximum torque as 5729.6 into 10 to the power of 3, which will be equal to pi into d cube into tau is 60 divided by 16. So on cross multiplication and simplification, therefore D, that is the diameter of the shaft based on the strength criterion, will be equal to 78.64 mm. Now similarly, we want to find out the diameter of the shaft based on the torsional rigidity or torsional stiffness. So from the torsional equation, we have G into theta by L will be equal to T max by J, where J is the polar moment of inertia of the solid shaft, which is pi d to the power of 4 by 32. So on substitution, so T max is given to be 5729.6 into 10 to the power of 3 divided by pi d to the power of 4 by 32, because it is the polar moment of inertia. So that will be equal to G, which is 0.8 into 10 to the power of 5 into theta is 1 degree, that is 1 into pi by 180 will be equal to 20 times D, which is the length. So on cross multiplication and simplification, the diameter of the shaft based on the torsional rigidity D is 94.2 mm. So we have found out the two diameters. One is the diameter of the shaft based on the strength, which is D equals 78.64, And similarly, the diameter of the shaft based on the torsional rigidity, which is D, will be equal to 94.2 mm. So base select the bigger value, bigger diameter as the permissible value. So therefore, the diameter of the solid shaft D will be equal to among 78.64 and 94.2 mm. So 94.2 is the bigger one, and hence you adopt this value for the future discussions. So the diameter of the solid shaft D will be equal to 94.2 mm. So this is how you will be able to solve this particular problem. Thank you.